There is something in this story that should not be able to exist. It is contagious. It is always fatal. And it has no DNA, no RNA, no genes of any kind. It isn't a virus, a bacterium, or a parasite. It isn't even alive. So the things we use to kill germs have nothing to grab. Boil it, soak it in disinfectant, run it through a standard hospital sterilizer, and it can still infect you. It can hide in a body for 50 years, then take that body apart in months. Science first met it at a funeral in the highlands of New Guinea. You may know this one by a lurid nickname, the Laughing Death. Most tellings stop at the horror, a remote people, a trembling sickness, and a shocking discovery about how it spread. But the discovery wasn't really the funeral. The funeral was just the door. What walked through it was a brand new kind of infectious agent, one that broke a rule biologists thought could never be broken. And the consequences are still sitting in our hospitals, our food supply, and maybe in the way our own brains fail as we age. In the 1950s, in the eastern highlands of what's now Papua New Guinea, the Fore, people were dying of something they called kuru, their word for trembling. It began with a stumble that wouldn't go away. Then balance failed, then the hands, then speech. Within a year or two, almost without exception, the person died. No fever, no wound, nothing that looked like an infection. And it struck with an impossible pattern. It killed women and young children and spared grown men. The reason hid in how the Fore grieved. When a relative died, the close women and children consumed part of the body, what researchers call transumption. It was not savagery, it was love, a way to keep a mother inside the people who loved her. But it was also the exposure. So stay with me, because the real discovery wasn't how kuru spread. It was what was spreading. At first, nothing in 1950s medicine had a shelf for this, a disease with no germ, no fever, and a pattern drawn by a funeral. The first real crack came from an experiment that should have failed. Researchers put material from a kuru victim's brain into chimpanzees and waited. For years, nothing. Then a chimp began to tremble, exactly like the Fore. Something physical had moved from the dead to the living, and no one could yet say what it was. The answer was so strange that the man who proposed it was treated as a crank. In 1982, a neurologist named Stanley Prusiner argued the agent wasn't a virus at all. It was a protein all by itself carrying no DNA or RNA. He called it a prion. To see why that got him ridiculed, you have to know the rule it broke. Biology took it for granted that to make more of yourself, you needed genes for the next host to copy. Prusiner was describing something with no genes at all. Colleagues called it impossible. He was right, and it won him the Nobel. Here's the trick, and it's unlike anything else in disease. Your body already makes this protein, a normal, harmless one, folded into a healthy shape. A prion is the same protein folded wrong, and the wrong fold is contagious to the right ones. When a misfolded prion touches a normal copy, it forces that copy to collapse into the same bad shape. Now there are two. Those two corrupt two more. It's a chain reaction made of origami, one molecule teaching the next to fold into a mistake until the brain fills with clumps and quietly fails. There's no code to interrupt, nothing alive to kill. That's what makes a prion so hard to stop. Everything we use to destroy a germ wrecks something it needs to live. Its membrane, its machinery, its genes. A prion has none of those. It's just a stable, badly folded shape. It survives boiling, the disinfectants that kill viruses, even formaldehyde, which can preserve it for years. It can survive a standard hospital autoclave. And then there's the waiting. The Fore mostly stopped the funeral practice around 1960. If kuru behaved like a normal infection, the deaths should have stopped. They didn't. People kept dying into the 1980s, and confirmed cases appeared after the year 2000, from a single childhood funeral more than 50 years before. Now put that in a modern hospital, an agent that shrugs off sterilization with an incubation that can outlast memory. In rare but documented cases, the disease has been passed by medicine itself. Contaminated neurosurgical instruments, grafts of tissue from the dead, a growth hormone once harvested from human cadavers. It's the same mechanism the Fore met at the funeral, only now it rides a surgical tray. And in the 1980s and 90s, the same kind of agent spread on a scale the Fore version never reached, not through a lab, but through the food chain. British cattle were fed rendered protein recycled back into cattle, and mad cow disease tore through the herds. Then it crossed into people who ate the beef as a human version called variant CJD. And here's the thought that turns the story inward. The defining move of a prion is templated, misfolding, one bad shape recruiting good ones into the same error. In the last 2 decades, researchers found that other proteins in far more common diseases seem to spread through the brain the same way. The amyloid and tau of Alzheimer's, the alpha-synuclein of Parkinson's. To be careful, these are not classic prions, and there's no good evidence you can catch Alzheimer's from anyone. This is prion-like seeding inside one nervous system, not contagion. But the core trick, a misfolded shape templating its neighbors, may be something our own aging brains can quietly do. So strip away the nickname and the horror, and look at what science actually found here. Not a curse. A thing that is contagious without being alive. That makes more of itself with no genes to copy. That ignores the tools we trust to keep us clean. And that waits longer than we remember. Biology had to admit that infection could be nothing more than a shape, and that the same trick may be quietly at work in the way our own brains fail as we age. The box we built for what counts as alive and what counts as infectious was always too small. Kuru is just where we first found the edge. This has been the Odd Hypothesis.